Generative art is a beautiful thing, and the fact that it's driven by code only makes it more enjoyable to behold. It's procedurally generated, unending in its compositions, and instantaneous in its production. These concepts prove incredibly useful to bridge the gap between the data structures of a machine and the eyes and mind of wonderful humans. This is procedurally generated symmetrical art, visually akin to Space Invaders or pixelated ink blobs, and as far as I can tell, the brainchild of another programmer, Eric Davidson. Links to his information are in the description below. Now let's code these awesome renditions ourselves. We're going to build off the previous video's code base, where we rendered the Doom fire screen in SDL and C++. And we can do some quick engine improvements before we get started on generating art. Let's start by letting the engine handle all SDL window creation and render presentation. To achieve this, we'll extend our engine loop to take a function pointer to the game's setup and teardown functions, as well as parameters for window title and starting resolutions. We then create engine level setup and teardown functions responsible for SDL management and move our rendering code to the engine draw function. We then test that our code works by outputting to the console and ensuring a window does appear. Before we code, let's take a closer look at one of these invaders and establish some concepts. The invader is a 2D grid of color cells. The colors are chosen at random and are roughly distributed in equal parts to black colors. And note the symmetry is across the vertical axis and not across the horizontal axis. For the purposes of this project, we'd like to fill our screen with different renditions of these invaders, so let's set up some data to do that first. We define some data structures to accomplish this: the width and height of an invader, the render size of pixels, and for the invaders themselves, if we consider each one as a grid of colors, we can represent many of them in a list of these colored grids. This is represented by our SDL color double pointer variable we are calling invaders. We use our setup and teardown functions to allocate and free the memory to hold a maximum number of invaders. Then we define a function that can loop over our list and generate the art for each invader. Once we free ourselves of compiler errors, we can write our main artistic algorithm. But before we do, let's look again at the art of the invader. Each invader has its own unique palette that consists of 3 random colors and 3 black colors. There is vertical symmetry within the invader, meaning that as we render out a row, we need to have both sides of the row match one another. We can accomplish this by defining a stack of colors. The first half of the row we randomize with colors which are chosen from our palette. For the second half, we create a mirror of the first. To code this, we create a palette of colors, then loop over each row, creating our stack of color choices. The first half of the column uses a set of random colors, the second half the reverse of this. And if the invader has an odd width, a special case is added to not mirror the center. We also support some optional padding to ensure our art has a black border. All that remains is to create our drawing logic, which will loop over our list of invaders, then loop over the invaders' pixels, drawing each pixel as a colored rectangle to the screen. Once a drawn row has surpassed the width of the screen, we will move to the next row and continue. And to tidy it up, we ensure our invader art is centered in the window. The last piece of this puzzle is creating our function to generate a random color palette for each invader. The logic is simple. The first 3 colors are randomized to RGB values between 40 and 255 to ensure they're not too dark. The last 3 are solid black. This would be a great place for us to introduce any color palette rules we wanted, such as triadic colors, grayscale, complementary, etc. Hey, that looks pretty good. Sort of. It looks like our randomization logic's off. Let's make sure we're differentiating our seed for each invader we create. Beautiful. But we aren't finished yet. Let's add some controls to regenerate and resize our art at runtime. If F is pressed, we can enter a full screen mode. If R is pressed, we can regenerate a new set of invaders. And if up or down is pressed, we can dynamically change the size of the invaders we render. Now that all of our code's in place, we can generate an infinite number of these wonderful generated art pieces. Regardless of the size, they are beautiful to behold. I hope you take this code and run with it and make something else really cool. And go ahead and check out Eric's GitHub, where you can find more information and other types of generative art he's created. Well, that should make this video a wrap. Until next time, get out there and write some awesome code.